Okay, hi everyone. Thank you very much for joining us today for our webinar on which engineering degree is for me. My name's Nicole. I work in the Prospective Students Office here at Flinders University, and with me today I have Marissa, who is the expert in this sort of area. I know a little bit about all of our courses at Flinders, whereas Marissa knows everything, or most things, in regards to the College of Science and Engineering. So largely today Marissa will be the one speaking, but then I might chime back in back towards the end of the webinar. So I will hand it over to you, Marissa, and thank you very much.
So if, as we go through, if you come up with any questions that I can't answer or Nicole can't answer, we'll be able to find the right people, dig up the information for you and get it back to you at some point in the future. So don't worry too much about that. Okay, so first of all, let's start off with why you might choose Flinders to do your engineering degree. So one of the really great things is that we have this what's called a WIL placement, so it's the work integrated learning. So all of our engineering degrees, you have a 20-week placement. That means that we help support you to get this work placement in some kind of industry that relates to the degree that you've chosen to study. There's that continual interaction, as it says, between the industry partners and Flinders, so we make sure that you're supported through that 20-week experience. It gives you a chance to learn what it's really like out in industry, and it gives you a chance to prove what you can do to these potential future employers as well. So what you find is that a lot of students actually end up with their first job from having this opportunity. Also what's really cool is you're not limited to just doing it in Adelaide with us. You can do it interstate, you can do it overseas. If there's somewhere that you've got in mind that you'd like to potentially work, then that's a great option for a place to go and do your WIL placement. All of your engineering degrees you do first year at a combination of our campuses, so you do a little bit at the Bedford Park campus, you do a little bit at Tonsley campus depending on what your topics are and how they fall, but from second year onwards everything that you do is at our Tonsley campus. So that's our brand new beautiful campus that's it's got the specialised teaching equipment in there, the teaching spaces, all the labs that are particularly geared for the various engineering disciplines. We've also got really cool research labs there that, especially when you get into the later years of your degree, you can get involved in projects, whether that's extracurricular stuff or through your topics, that will give you access to those spaces so you can learn some more of the nitty-gritty that goes on behind the scenes really, which is quite cool. Another really cool thing about Tonsley is that it's got industry partners on site, so some of them even share our building with us, others are in individual pods outside of our building. What this means is that you've got startup companies and large established companies all doing work all the time, very, very close to where you're studying. And when they have opportunities come up for project work, maybe they've got a short-term thing that's come up, often those opportunities get shared with our students. So again, you get an opportunity to network, to build up your skills, earn a bit of money, pop it on your CV. So it's a really positive thing for our students. There's also options to combine your engineering degree with other engineering degrees, with other science degrees, and also something called Design and Technology Innovation, which helps you learn how to be an entrepreneur, how to innovate, how to do product design, and sort of all those business aspects as well. So it's something we can talk about in a little bit more detail later, but it's a pretty good thing if you want to add some value to your degree. So we have a whole stack of different specialised engineering degrees. They're all 4 years because they include a compulsory honours year, which means you get to do more project work, more research-based work in that year to prepare you for that sort of stuff going forward. So you can see a list here of the different degrees that we offer, and I'm going to go through each of them and give you a little bit of an overview of what they are and where they can lead to. And there you can also see the Design and Technology Innovation degrees listed as well. You can do that as a standalone, and when you do it as a standalone degree, it's a 3-year degree, or you can combine it with your engineering if you like. Okay. Also, just to give you a bit of the big picture idea of what's sort of going on in engineering, computing and mathematics, you can see the little diagram here shows you where a lot of the overlaps are. Because you find all of these areas, there are going to be overlaps. You've got common skills from one area that apply to another. What that means for you as a graduate at the other end of your degree is that you can be quite flexible with a lot of the jobs and things that you go for. So you might have done robotics engineering, right? So you can find that sort of in the, will it show up here? over here. There we go. So if you have a look, you've got your robotics engineering, but robotics engineering combines skills in electronics, combines skills in mechanical engineering. Depending on what specialisations you do, you could pick up some biomed, some electrical. There's all sorts of things going on there, which means that going forward, if you're looking for jobs, you're not limited to jobs that are just labelled robotics engineer. You can go for things that are electronic engineering or mechanical engineering or even broader than that. So it's something just to keep in mind that you get quite a broad skill set in all of the different areas. Okay, so we'll start off looking at the individual degrees. So we've got biomedical engineering. So this one looks at maintaining, planning, designing systems, equipment, processes, everything related to healthcare. Okay, so you get a good set of skills. Oh, where's my other picture? You get a good set of skills in engineering, so you get the fundamentals in engineering, things like mechanical engineering, electronics, all that sort of stuff. You learn all of that. But you also have a solid foundation in medical science, so you do physiology type topics, and depending on what specialisation you pick, you can sort of determine what pathway you build with that. So you can see there's some suggested jobs listed there, but really it's really very broad. Lots of different things you can end up going into. So you could be working in research and development, you could be working in a hospital helping to maintain the equipment that they have there. You could be government-based or private. There's lots of opportunities around. There's also software-based things, so you might be interested more in the software stuff, and you can look at simulations and medical training tools as well. So lots and lots of things going on there. So I'll just go through each of these very, very quickly, but if you've got questions about one in more depth, let us know and I'll try and dig in a bit more. Okay, so civil engineering. So as you can imagine, civil engineering, we come across the products of civil engineers every day, all day. So what they're looking at is infrastructure. So our built environment, our water resources, we draw a lot of our civil engineers into mining, transport industries. So there's lots of stuff going on there. So you need to know how to, again, plan, design, but also rehabilitate. So a lot of times you might come across infrastructure that it's critical, but clearly, it's been there for quite a long time. You've got to work out the best way to support, maybe rebuild, without disrupting something that's currently in use too much. So it can be quite challenging, which is good fun. That's what we like as engineers, a good challenge. So civil engineers are in great demand. You can imagine anywhere that has this sort of infrastructure, so any city, any built-up environment is going to need civil engineers. So this means local governments, different government agencies. You could work as a consultant, lots and lots of different things that you can get involved there. But we're looking typically at large scale stuff. Yeah, good. Okay, so computer and network systems engineering. So this is one where we're looking at the interface between software and hardware, okay? So it's a combination of electronic engineering, computing, computer science and networks. So you need skills sort of at both sides of the interface so that you can understand how they behave together. Computers and mobile devices and integrated circuits, they're just critical to everything that we do these days. So again, wherever you're using these kinds of technologies, we're going to need computer and network systems engineers. So you've got to be quite creative in this area because you're trying to develop things that we're going to be using in the future. And as you would probably know, just from the technology that you use yourself every day, things move really quickly. Things are developed at a really fast rate. So you need to have the skills to keep up with that, work with what's coming out, develop your own stuff. It's quite a cool area. So some of the areas that our graduates have worked in and got their first sort of roles in are things like processing visual data and signal data. So that we can get those more, natural interactions with our technology. So things like your speech recognition and your gesture recognition are becoming more and more common. So these are actually some of the things that our computer and network systems engineers can look into. Smart instrumentation, so that's talking about sensors and things like that, so that your devices respond to you without you having to physically input things. embedded systems, mobile devices, robotics, software development. There's lots of things that you can head into with this sort of degree. But the focus is that you're looking at the interface between the hardware and the software and how we combine that. So electrical engineering, we've got electrical and electronic engineering. They're both overlapping, they're both similar in a lot of ways that they deal with electricity, but electrical engineering, we're looking at the large scale systems. So we're looking at how we transmit power, how we generate it. Particularly we're interested in how we do it in a renewable and a sustainable way. So you can see that our electrical engineering award, we have two specific sort of pathways that we focus on. One is renewable energy systems, so your solar panels, your wind farms, all that sort of gear. And the other is electrical drive systems, which is really quite interesting because this is where we look at things like electric vehicles, and we have a real interest in marine vessels and things as well, so ships and submarines, which if you're particularly interested in that, we have a sort of more specialised degree that I'll talk about later as well. So electrical engineers, this is one of the areas that we do really need in Australia, and even locally we've got our SA Power Networks. It's one of our big employers of electrical engineers. So yeah, this is a particularly good area to get into if you're looking at that. But as mining and in particular defence are growing in our state, this is one of the areas that they're drawing on. So Flinders has quite good connections with quite a number of industry representatives and projects and things that are going on, so it's a good opportunity to get involved in that space if it's something that might interest you. So like I said, we also have electronic engineering. So electronic, we're still dealing with electricity, but now we're looking at the smaller scale stuff, usually lower voltage stuff, and rather than being interested in how we transport the electricity itself from where it's generated to where we need it, we're interested in how we can use electricity to send signals and information from one place to another. So the focus is a bit different. But again, sort of like what I was saying with the computer and network systems, we use electronics every day. So all of those devices and things, they need electronic engineers involved in developing that. So again, this is something that is actually a strength for South Australia. Sometimes people, and Adelaide in particular, sometimes people aren't aware of this, but electronics is one of the areas where we have, for our engineering space, quite a few various employers in different areas. And industry, so it's a strength for us. So another good one to get involved in if that's something that you're looking at, whether the opportunities are here locally or whether you need to go elsewhere for them. This is one that we actually do have a really good solid base locally in Adelaide. So you can see some examples of jobs and things like that. Your aircraft and ship systems, robotics, all sorts of things there that it's just one of those really good fundamental skill sets that applies to all sorts of different areas. So if you're interested in developing your own circuitry, your own components, things like that, then it's a good one to consider. Robotics is quite cool and it's quite unique to us. There are a few options, but we had one of the first here, so we do it quite well. And we have some really nice specialised facilities down at Tonsley. So you can see in some of our photos here, get my screen up. So we've got a couple of our beautiful robots that sit in our teaching lab that our students get to work with here, Baxter and Sawyer. They're nice industrial robots. Then here we have what's called our hexapod. This was one that was developed in-house and it's above gold standard, which means it's better than what the standard's written to. So it can function at a level that's beyond what other places have access to. But this is used in our biomedical engineering, but we developed in-house. So our robotics engineers built it and then we can apply it in some different areas. So that's also kind of cool to know that we can do those sorts of things. So robotics, again, we combine things like electronics, mechanical engineering, software engineering, all of that comes together in robotics. We need to write software, but we need to use sensors. We need to build things that can move in sensible ways and useful ways for the different tasks. And typically we're using robots in areas where either it's dangerous to send people, or it's difficult to send people, or it's really repetitive or laborious, and that using a robot frees the humans up to do the more interesting work. So what that means is that robotics is typically used in industries such as automotive industry, defence, medicine. You find we do use a lot in the medicine. That's why there's that nice crossover with biomedical engineering, and mining. as well as your sort of standard industrial factory settings. So again, this is one where it's a niche area, but because you get those diverse skills, when you're going out and looking for jobs, you can look in the electronics engineers area, or you can look at working as a mechanical engineer. You're not limited to only picking up jobs that are sort of labelled as being a robotic engineer. So it gives you scope. Mechanical engineering is another one of those really nice fundamental ones, where you find your mechanical engineers are in demand in all sorts of different places because their skill set is quite broad, so it can be applied to all sorts of different things. So you're looking at understanding how materials behave, how things interact, so you can build systems, parts, structures, typically lots of movement, things like that, to address, as it says, real world problems. But exactly what they are can be really, really broad. So to give some examples of bits and pieces that our students work on, I've got some photos here. Here is just one of our student projects. So this is from our Warman Cup. So they've developed in conjunction with the robotics engineers. So we have the students working teams, and they have to develop little robots that can complete a particular challenge. So that's a good project that they do, as part of their studies. But then we've got bigger scale things, like here we've got our solar car. So they've just launched that this week, which is really cool. Now, as you can see here, we've got a whole team of people with really diverse skills. Mechanical engineers are critical to this, obviously, we're building a mechanical system, but we're also going to need electrical engineers because we're looking at solar panels and things like that. We're going to need electronics engineers for all the bits and pieces inside. We're going to need software engineers and computer scientists and things like that for writing all the software that draws it all together and manages it all. And so there's all sorts of things that go on in there. And then we have our student team. So this is our motorsport team, and these guys have developed a racing simulator, which is quite cool, and this is mostly made up of mechanical engineering students as well. So just a few examples of bits and pieces that our students in this area can get involved in. Okay, so I mentioned earlier that if you're interested particularly from the electrical engineering side of things, if you're interested particularly in the drive systems, that another option could also be the Maritime Engineering degree. So this is one where you actually do 2 years with us. The first 2 years you do with us, and then you do your 3rd and 4th years over at the University of Tasmania at the Australian Maritime College. So your first 2 years, you're based mostly at Tonsley. We've got specialised equipment. We've got a tank that you can build your various devices in and test them out. So we've got those really cool facilities. And our first 2 years prepare you to decide which pathway you want to specialise in once you get over to Tasmania. So you can specialise in naval architecture, ocean engineering, or marine and offshore systems. And if anyone's interested in that, I can give you a little bit more detail on each of them later. So we see this is quite specialised. You're focused on maritime vehicles. You're focused on also the permanent structures, but in a maritime setting. So it's not just vehicle based. It's also things like as it says here, your oil and gas installations, coastal engineering projects, ports and harbours, all those sort of things where you're interacting with the marine environment. This gives you the skills to do that because it's a bit of a specialised space. You're dealing with, salty water and sea air and all that sort of stuff. You've got to understand how that interacts with the materials a little bit more than perhaps if you were doing something, in an urban environment. So yeah, and you can see down here again, jobs listed are more specific. It's not to say that it's hard to, particularly hard to get them, but they tend to be more specific because your skill set is more specific. So you would be wanting to look at something in the shipping industry or transport or ferries and shipbuildings, things like that. So yeah, something cool to keep in mind. 2 years with us and 2 years in Tasmania. So there's also software engineering. You can choose whether you want to take more an electronics pathway or more a computer science pathway within this. So software engineering, we're looking at not just writing software ourselves, but we're interested in the whole life cycle of software. So we're interested in looking back at, how do we find out from users what they want, how do we design that, write it, then how do we maintain it, roll it out, how do we manage it once the software is out in people's hands. And then, like I said, you can choose one of your sort of focuses, whether it's electronics or computer science. Now, if you're interested in the electronics side, then you'll also take subjects in things like microprocessors, sensors, control systems, so that you understand how to integrate that and communicate with those in your software. If you're more interested in the computer science stuff, then you're more likely to look at things like databases and network systems and human-computer interaction. So that's looking at how we interact with computers, what we enjoy, what we find natural, what we find efficient, all those sorts of things. So it's the human factor stuff that's quite cool. So then once you complete that degree, you can work as a software designer. You will then also have the skills to be able to work with all sorts of different platforms. So it's not like you're limited to just software that you deploy on a PC or something like that. Because you've got that other context, you'll be able to develop software that fits all sorts of interesting devices. So it might be smart cards even, it might be mobile devices, simulators, there's all sorts of different things there, but you'll have the skills to adapt to all those different environments, which is quite cool. So that can be a bit overwhelming sometimes. There's a whole bunch of different engineering degrees, and particularly as a student coming through, when you haven't necessarily had a taste of those yourself before, it can be hard to decide which one you might like to choose. So some things to keep in mind is, first of all, even those specialised degrees that we've just gone through, most of them have a common first year. So you'll get a taste of electronics, mechanical engineering, software engineering in your first year. So even if you get to the end of the first year and you decide, oh, look, I signed up for electronic engineering, but I actually really loved the mechanical topics, you can typically do a transfer across. There's a few caveats in there that we can discuss if anyone's interested, but it's usually not too difficult to do if that's where you want to head. If you're coming in but you really just have no idea which one of them you want to do, then a good option is this flexible entry. Okay, so this is a 1-year degree, and if you're looking for it when you're putting in your preferences, it's just called Bachelor of Engineering Honours. It doesn't have a specialisation name in it. And the idea is that you do that basically common first year, and at the end of the first year, then you make your decision about where you're going to go. If you're interested in engineering, but you're either worried about your entry score, your ATAR, or you're worried about prerequisites or something like that, then there's also this option to do a Bachelor of Engineering Science. So that has topics to support you if you don't have a strong background in maths or physics, to try and get you up to speed. It has specialisations in biomedical, civil, electrical, electronic, mechanical and software, as you can see there. So you can use it as a pathway to get into the specialised 4-year degrees in those areas if you like. So it's a good backup option to know that's there. But if you think you might need that, then it's probably a great idea to have a chat with us and get some more details about all of that. So a typical study program, as you can see here, like I mentioned, there's a common first year for most things. So in addition to the things I already mentioned, like your electronics and your mechanics and things like that, you'll do professional skills, which will help you with presentations and report writing and teamwork and things like that. You'll do some design topics, things looking at the properties of different materials, and you'll do maths topics. So there's all sorts of things there that are fundamental. Regardless of what type of engineering you do, you're going to need all of those. So you get to do that in your first year. Also, like I mentioned at the start, from second year onwards, you're based at Tonsley, so you get access to those specialised teaching labs and things like that, and all the good equipment that's in there. And again, recapping what we mentioned earlier, all of our engineering degrees have that 20-week work placement. So again, another opportunity to go overseas if that's what you like, or interstate. You can make that sort of suit what you want to do with your future. And it's a great opportunity for networking, getting a foot in the door for your first job. But you've got the support there while you're going through it from the university, which is really cool. Other ideas as you're going through, if you want to sort of maximise your time at uni, you might consider a combined degree. As I mentioned earlier, there's that design, technology and innovation one, so if you think you might be interested in the future in things like business or innovation or entrepreneurship, that's a good one to get involved in. Gives you the skills you need to turn your own ideas into a startup business or a new product or service or something like that. But you can combine pretty much any engineering and science degree, so there's so many options. But if you've got something in mind, again, have a chat to us and we can help you with suggestions of what might work well or not so well. You can do Innovation and Enterprise as a Bachelor of Letters as well, but so that can be combined with any degree, even if it's not engineering and science. But if you're already going down the engineering science pathway, then the technology specific one is probably the one that will fit best with your needs, but it's something that we can chat about. Again, opportunities to study abroad, so not just in your work placement, there are other opportunities to take subjects and things at universities overseas. And once you've done your degree, if you're interested, there's options for further study, so you could either do masters or PhDs in various areas. But that's something that most people probably want to think about a little bit later in their degree, but we can give you more information about that if you want.
Cool. So, thanks Marissa, you can take a breath now. I'm just going to scoot back in. Before I get into how to apply for university, I actually do have a question that's come through. I think you've covered it largely in the, I'll scoot back over, is it got asked by, is the industry experience guaranteed? Yes, the 20 weeks
yes, the
is
20
compulsory.
weeks is compulsory. Yeah.
And then there's also the concern that getting that first internship or that first years of experience is really hard. Do you have any tips or advice on that side of things? On how to
I think as you're going through your degree, you will get presented with opportunities. So things will come across your desk for extracurricular projects. You know, it might be summer schools, it might be projects that are going on that they're looking for students to support with. It might be, as I mentioned, you know, startup companies that are sharing the space with us that have opportunities. Try to take those sorts of things up as much as you can, because then that sets you apart. You'll end up with a more unique skill set. You'll also network with the people that you're getting those opportunities from. You know, they'll know what you're capable of, and then when they've got a more permanent opening, you're going to be the first person that comes to mind. So do take up all those opportunities as much as you can. I think that's something that we see our really successful students doing, and they get quite good outcomes at the other end. I think also be flexible, be aware that as I mentioned, you know, as an engineer, you're going to have skills that apply in all sorts of different areas. You don't have to stick to the label of your degree. We even find that businesses are looking for engineers to hire just in management type positions, project management type positions, because they know that engineers have the skills to manage that sort of situation, even if it's not an engineering specific thing.
You're right.
So engineers are in demand in all sorts of different areas.
There you go. I hope that answers your question for you there, Harry. If you have anything else, feel free to type it through.
Yeah.
In the meantime, I will just spend a minute on how to apply to university if you aren't familiar with this. As Marissa did touch on, there are, this is largely where prerequisites fall into play. So prerequisites are topics that you'll need to complete in Year 12 to be eligible to apply for degrees. And our engineering, computer science and maths degrees is where our prerequisites lie. So make sure you have covered those. If you haven't, as Marissa mentioned, there's pathways into it. So we can always have a chat to you about that and what the fastest pathway into the degree you want is. So you do need to apply through SATAC if you are wanting to come to university, and we do recommend you do this by the 29th of September. That way you'll avoid a late fee. So you can submit your application, but then you can change your preferences around right up until the 3rd of January. So you don't need to lock in exactly what you want to do. You just need to submit your application and pay that SATAC application fee, just so you don't get dumped with a $130 fee into it.